Okay, cool. So we've talked about accelerated motion, non-accelerated motion already, right? And that all deals with standard 2. So standard 2 is this. So unit 1, standard 2 is pretty much that. So I can analyze and construct velocity versus time graphs. Okay, so unit 1, standard 2 is the analysis of velocity versus time graph. And velocity versus time graph also brings to rise of what we call acceleration versus time. So both of these are pretty much what we're looking into. So what we've worked with so far is accelerated motion, and non-accelerated motion. So let's go through what those mean. So what is accelerated motion? What can you do if you're accelerating, pretty much? So if you're accelerating, there's 3 things that can occur. What are one of those things? What's one of those things that can occur if you are accelerating? Trying to see this out. Feel free to unmute yourself if you want to just add, or you can write it in the chat.
Speeding up.
Yeah, so one thing is you're speeding up, right? So you could definitely be speeding up. What's the other thing you could do if you're accelerating? So you could speed up, or remember your body can actually feel acceleration.
You slow down.
Yeah, you can slow down. And the last thing you could do, and this is something we're not really going to analyze with the velocity time graph, right? It's just changing directions. Okay, this is just kind of a refresher when we first talked about accelerated versus non-accelerated motion. So changing directions, we're really not going to analyze using a graph. It doesn't have linear motion, and linear motion is really what we're focused on. So here, these 3 things are if it's accelerated motion, right? And we're going to analyze speeding up and slowing down today. Okay, non-accelerated motion, right? If you're not accelerating, you could be doing 2 things. What are the 2 things you could be doing?
Constant velocity.
Good. So you can be moving at a constant velocity. Or you could be doing one more thing. What's the other thing you could be doing if you're not accelerating?
Not moving.
Yeah, so no motion at all. Okay, so if you have no acceleration, you have constant velocity or no motion whatsoever. So there's 3 ways, right, we can analyze. I'm going to say graphically analyze. That motion. Okay, so looking at this, I think we have someone in the waiting room. No, okay. I'm going to keep that up just so I can see it. Okay, so looking at those 3 ways to analyze, right? There's the first way you can do it and graphically is through a displacement versus time graph. Okay, so that's the first way you can analyze this. You can use a displacement versus time graph. The second way, right, is a velocity versus time graph. That's the second way you can analyze this. And then the last way is if we use an acceleration versus time. All right, so here's pretty much how this is broken down. This is stuff that we've already talked about, right? Displacement versus time, that's all the stuff in standard 1. So this is all standard 1 material, and that's what we've already quizzed on, right? Standard 2 focuses on these two, right? So standard 2 focuses on velocity time and acceleration time. So what is it that we can that we can kind of move over from our knowledge of how a displacement time graph works? So we know a few things about a displacement time, and I'm just going to separate these two so we have some columns here. All right, so they have some very similar things. Displacement versus time graph, right? There's what does it actually graph? So in reference to time, right? A displacement time graph looks at what? Or what does it graph in reference to time? So what is a displacement versus time graph in reference to time? I think it's in the title.
Displacement.
Yeah, so the reference to time, right? A displacement time will graph, I'm going to say the displacement, meaning its position, right? So you can see this object's position as time moves on with a displacement versus time graph, right? So, oh, didn't mean to do that. Okay, good. So what does the slope of this graph tell you? What does the slope equal if we have a displacement time graph? It starts with a V.
Velocity.
Yeah, so it's your velocity, right? So if this positive slope, you have positive velocity, meaning you're moving to the right. If it's negative, you have negative velocity, meaning you're moving to the left. So that's what this slope represents. Okay, so if we're looking at a displacement time graph, right, we're looking at, okay, if there's a dot on it, it's going to let me know its position. If there's a trend, meaning there's a slope, it's going to let me know its velocity. So this, we can analyze in similar fashion a velocity time graph, but it's going to be a little bit different. So this one, right, in the same fashion, it's still using time as a reference. So in reference to time, it's going to graph the velocity. So it's letting you know how fast it's moving. So each point on a velocity time graph is telling you two things. Is it positive? Is it negative? And if it is, right, that point, it's moving either to the right or the left. And then the further away from the origin means the faster it's moving. So in reference to time, it's graphing its velocity. The slope of this graph is going to equal its acceleration. So if it has positive slope or negative slope, it's going to let you know whether or not it's speeding up or slowing down. Okay, now it all depends on the actual motion, and I want to create a key before we go through it. Okay, so notice we're analyzing all of these graphs in very similar fashion. We're looking at what is the point doing, and then is there a specific trend. Acceleration versus time is a little bit different, and the reason so is that we're only looking at this for its acceleration reference. And what I mean by that, actually, I'll explain what I mean by that in a second. So in reference to time, this graph is going to graph the acceleration of the object. We're not going to focus, so don't focus on the slope, right? So in this case, acceleration versus time, we should not focus on the slope. It should always be flat. And the reason being is that if you have changing acceleration, it gets a little bit complicated. We're not going to go into that within the scope of this class. So the only thing that I want you guys to really think about is there's 3 ways to analyze graphically, okay? Each of them represent different things. So a point on each of these graphs represent different things. And then the slope of these graphs gives you pretty much the next graph. So notice this, displacement versus time graph, the slope of that is going to equal the velocity. A velocity versus time graph, the slope of that is going to equal the acceleration. So whenever you're looking at the slope, it kind of shows you what the next graph is going to look like. Okay, so one thing I wanted to do, and we have 12 minutes left, so we have plenty of time. One thing I wanted to do is I wanted to create a key for you guys. And what I call is like, this is a motion key. So a motion, I'm just gonna say a motion graph key. So thinking about all the different kinds of motions we can have, I want you guys to at least have in your notes what they should look like, right? So if we have like no motion and you're looking at a graph and it's a displacement time graph, I want you guys to have in your notes like what kind of thing it should look like. So let's start with non-accelerated motion. Okay, so non-accelerated motion, right? There's three ways we can analyze it, right? There's a displacement time, velocity time, and acceleration time graph. So let's start with one of the scenarios that could be a non-accelerated motion. So let's start with no motion. So it's not moving whatsoever. Okay, this is what we're analyzing right now. So if you have no movement, there's three ways or three graphs that can represent no motion. So one of them being a displacement time graph, the other one being a velocity time graph, and the last one being an acceleration time graph. So go ahead and draw these into your notes because you will need them. Okay, so if there is no motion, I'm going to start everything at the origin just for simplicity's sake. So if there is no motion, what kind of displacement time graph are you expecting to see? Are you expecting to see a slope line or a straight line? Or a flat line, I should say. Sloped or flat?
Slope.
So if there's no motion, if it's not moving, would you have?
Oh, flat.
Yeah, it's going to be flat. So in this case, right, it's going to be flat all the way through. Okay, so if this is flat, right, if this is flat and there is no velocity present, right, what we're then looking at is that a velocity time graph, it's going to be plotted as 0. So we don't have any velocity in that particular graph. And all of these, right, they're not accelerating. So if there's no velocity, meaning you're not moving, you're not going to be accelerating. So you're going to be right across that 0 mark. All right, so those are pretty much if it's not moving. If an object's not moving, we should expect a flat line here. We should expect the line right along the 0 there. We should expect the line right along the 0 there. So that's if there's no motion. Well, what if there is motion? What if there's constant velocity? So what if there's constant velocity with rightward motion? All right, so what if we have constant velocity with rightward motion? The thing that we should expect, and let's go ahead and create the three ways we can analyze it. So displacement versus time, velocity versus time, and acceleration versus time. So looking at the three ways that you can analyze a constant velocity with rightward motion, right? For a displacement time graph, if we have constant velocity to the right, there should be some kind of slope. Will that slope be positive or negative?
Positive.
Yeah, so you're going to have positive slope. So from the origin, you're going to move away from that starting position, right, towards the right, meaning you're going to have positive slope. So that's a straight line, positive slope. Okay, so if this is positive slope, what it's saying is you have positive velocity the entire way through. So here you have positive velocity. Midway, you're going to have positive velocity. At the very end, you're going to have positive velocity. So this should be a straight line above the origin, right? Because whatever slope this is, let's say this is a positive 3 slope, this is going to be a positive 3 meters per second. Okay, now there is still no acceleration. So we're not speeding up, not slowing down. So this is going to be right across that 0 mark. All right, and I know some right now, like you're kind of figuring out like, whoa, what's like there's a lot of graphs going on. Again, we're just creating the key so you can go back and reference it. We're not necessarily explaining why or how just yet. We have a lab that's going to help you, like it's going to have you dive into this. We have different practice worksheets that are going to have you dive into this. So we're still going to dive into the why and how these look or why they do the certain things they do. For right now, let's just have a key. So when we are like stumped on a problem, we can go back and reference all of these different motion graphs. Okay, so we have about 6 minutes left. We still have some time to get more of these types of motions. So you have constant velocity. We had rightward motion before, so let's talk about leftward motion. Okay, so having constant velocity with leftward motion, we have this. And it's going to be hard for you guys to see it. What if I do this? Oh, perfect, don't fall. All right, sweet, that worked. All right, so constant velocity with leftward motion, creating on the graphs. So give me a second. All right, so we have displacement time, velocity time, and acceleration time. All right, so the only thing different between leftward motion, so between this set of graphs and these sets of graphs is that we have leftward motion. So this particular displacement time graph is now going to have what kind of slope?
Negative.
Negative.
Yeah, exactly. So now we have negative slope, right? So here, and I kind of messed that one up. So now we have this negative slope, right? It's pointing downwards. Now notice if positive slope gave you a positive velocity, right? It's right above that 0, the origin mark. Here, negative slope is going to give negative velocity. So right below that origin mark, okay? Now, it's still not accelerating. There's no speeding up, no slowing down. So it's right across that origin. Okay, so any questions on non-accelerated motion? This is all if it's not accelerating. All right, so let's move over to what if it is accelerating, right? So what if this is actually speeding up and slowing down? So looking at accelerated motion graphs, there could be really two things that we talked about that we're going to analyze. So it could be speeding up or it can be slowing down. Now, it could be speeding up to the right, and it could also be speeding up to the left. So thinking about those two, let's kind of start with that. So if something is speeding up, right, you can have rightward motion and leftward motion. So if it's speeding up to the right, okay, you should expect the velocity to start increasing in this presence. So rightward motion, we are going to expect there to be a few things. So the first thing is that a displacement time graph is going to, because of the fact that it's speeding up, it's going to gain more distance or be further and further away from the origin as time goes on. So what that's going to produce is it's actually going to produce a curved line. So if you're speeding up with rightward motion, right, let's start at the origin again for simplicity's sake. What's going to happen is you're going to start off going slow with not a lot of slope, and then you're going to increase more and more as time goes on. So you'll have something that is pretty much curving upwards. All right, now notice the slope in the beginning, notice the slope at the end. So if I were to put my pen right there and we look at that slope, it's a totally flat line, right? If we were to put my pen on this line, right, it's now a positive slope. So looking at this, it starts off at 0 and it starts speeding up, meaning it's going to get further and further away from this origin. Now it's moving to the right. So it's going to speed up and end up, right, with some velocity that is moving in the positive direction. So you should have velocity that's slanting upward. Now, because you're speeding up and you're moving to the right, you're actually accelerating, right? Your acceleration is rightward. It's positive and it's constant the entire time. Well, what about if we had speeding up in the leftward motion? Well, if we're speeding up towards the left, the only thing, it's very, very similar. The only thing that's different is the direction in which these lines are pointing. So let's go ahead and just go over those and then we'll call it a day. So looking at each of these, right, you have displacement time, velocity time, acceleration time. The only thing that's different about the one above and the one below is that it's moving now towards the left. So looking at leftward motion, it's pretty much what happened with the uniform motion stuff, the non-accelerated motion. So instead of this curving upward, this is now going to curve downward. It's going to curve towards the negative direction. And the reason why it's doing that is because it's moving left. Now the velocity, it's still speeding up, meaning it's going to get further from that origin, but you're going to have this negative slope. And the last thing is your acceleration will be negative. Again, for right now, don't worry about, well, I really don't understand what's going on with these graphs. We're going to analyze them deeper, right? We're going to have a deeper analysis of each of these. So the only thing we're doing is we're getting a key so we can have all of the different kinds of motion graphs present in our notes so we can go back and use them as a reference marker. All right, any questions so far? Does anyone need me to go back in the notes so you guys can see something? We still need 2 more sets of graphs, but we will do that tomorrow before we start the lab. Okay. All right.